Okay, remember in the last video we talked about the law signs. Now we looked at two cases of law signs where you're given two angles and a side. So that could be angle, side, angle. You get the two angles and a side included, or two angles and a side not included between the angles. Today we're going to look at the third case where you use law signs, which is side-side angle. The side-side angle case is often called the ambiguous case because in this type of situation you could end up with one triangle, no triangle, or two triangles. So it's ambiguous how many solutions you're going to have. So you could have no triangle could exist with the given information. You could form one triangle with the given information, or you could form two triangles with the given information. To determine which situation that you have, you need to be able to calculate certain values. Now I chose A and B at random here, but basically the A that I'm going to use in this table below, that just stands for the length of the side opposite the angle that you're given, because you're given two sides in one angle. So the side opposite the angle you're given is what I'm calling angle A. Side B, is the side adjacent to the angle that you were given. So A stands for the side opposite the angle given. B stands for the side adjacent to the angle given. H is, of course, the height of the triangle. So how to calculate the height of the triangle? We're going to go back to right triangle trigonometry. So here's the information given. We're given angle A, side B, side A, and then hypotenuse here is our height of our triangle. Now we can calculate this using our right triangle trigonometry. Sine of angle A, which we know is equal to H over B. So solving this for H, we find that H is equal to B sine of A. So whenever you're trying to figure out how many solutions you have, we're given the SSA situation, first thing you're going to look at is look at the angle that's given to you. Is that angle acute or obtuse? So let's look at the situation if that angle given is an acute angle. Next, you're going to compare the side opposite the angle given with the hypotenuse of the triangle. Now, if the side opposite the angle given is less than the hypotenuse, there's no way that you can form a triangle. For example, here is our angle A, here's our hypotenuse, and then if the side opposite angle A is smaller than the hypotenuse, now regardless, this little curved line here is if I rotated that line, that side to whatever angle, because I don't know that angle there, angle C. It doesn't matter how I move, what that angle measurement is, I still cannot form a triangle. It cannot reach that third side. So that's an example of a no triangle exists. Now, for one triangle exists, there's two possibilities. A could be exactly equal to the height. So the side opposite the angle given, if its length is exactly the length of the height of the triangle, then you're going to form a right triangle and you have one triangle that exists. The second way that you could get one triangle exists is if that side length opposite the angle given, which is A, is greater than or equal to the length of the adjacent side. So when you have an acute angle, if the side opposite the angle given is greater than or less than the adjacent side to the angle given, then you're going to form one triangle. It's going to look something like this. And this occurs if the height of the triangle is smaller than the length of the side opposite the angle given, but the length of the side opposite the angle given is smaller than the side adjacent to the angle given. Okay, so H is less than A, which is less than B. So here's an example of what this would look like. So here is angle A and side B that's given, which is our adjacent side to the angle given. Now, if our hypotenuse is this length, which is H, A is going to be larger than H but smaller than B. It could form a triangle like this one. But then I could rotate this, because that angle C could be anything. I can rotate this line here, this orange line, over to this point. And so I form this new orange triangle. Okay. And that could be one triangle. Or if you look at this pink triangle, this big triangle formed, that's another triangle that's formed with those three given information. So this is an example where two triangles exist. Okay, so those are the three situations that occur if the angle given is acute. Now, if the angle given is obtuse, there's only two possibilities: no triangle or one triangle. So how do I figure out if I have no triangle? Well, if the side opposite the angle given is less than or equal to the side adjacent, you're going to have no triangle, because angle A is acute, is obtuse. So since angle A is obtuse, it's the biggest angle in our triangle. So the side opposite it has to be the largest side in the triangle. It has to be the longest side. So if that side's shorter than the other side given, there's no way I can stretch that line to close up this triangle. And then the second situation when the angle A is obtuse is if A is greater than B. So if A is greater than B, then yes, if angle A is a obtuse angle, then as long as that side opposite angle A is, or the angle given is larger than that other side listed, I can definitely form a triangle. And it will only be one triangle that can be formed. So the rest of this video, we'll just kind of work examples here and figuring out how many solutions we have, and then working out and finding the solution. So the first thing I notice in this example is that my angle given is 42 degrees. So it's an acute angle. And so now I'm going to compare my side opposite the angle given, which is my A in this case, with the side adjacent to my angle. And I'm going to compare 22 to 12. So the side opposite my angle is larger than my side adjacent to my angle. So that's going to be that one triangle exists case. So my conclusion is I will have one triangle. Okay, so I'm going to make my little answer key here. Let's see, what pieces are missing? I know angle A, so I'm missing angle B and angle C, and I'm missing side C. So this is where I'm going to put my answers. So for the law of sines in this case, first thing we're going to do is I have that complete ratio for A. So I'm going to start by finding measure of angle B by doing sine of B over 12 is equal to the sine of 42 over 22. Solving for angle B by first multiplying by 12 and then taking the inverse sine, I get that the measure of angle B is approximately 21.4064. Now, on my answer key, I'm only going to write 21.41 because I'm going to round to 2 decimal places unless specified otherwise. But notice in my exact answer, I go to 4 decimal places. Now, for the rounding error on these problems, I'm going to have to use my previous answers, my rounded answers in future calculations. So to fix, kind of help offset that rounding error as much as possible, I want you to go to the double accuracy of what is. So since I'm requiring 2 decimal places, I need you to at least write your answer to 4 decimal places, and that's what you're going to use in future calculations. So to find my angle C, I'm going to subtract my 2 given angles from the 180. Notice I'm subtracting 42 and 21.4064 to using 4 decimal places here. And I get that angle is 116 degrees, 0.5936, but in my answer key, I'm just going to write that that's 116.59 degrees. Then I'm going to find my measure of angle C, or side C. To find side C, I'm going to have to use the sine of angle C. Notice again, I'm using all 4 decimals in my calculations of the law of sines formula. And then I'm going to go back to the exact one given, the side B over sine of B. And I'm going to solve this equation for C by multiplying each side by the sine of 116.5936 degrees. Punching this into my calculator, I find that side C is approximately 29.40 degrees. So 40 inches. So 29.40 inches would be my answer. So that's how you solve with the law of sine. So the most important thing with this case of SSA is that we're going to have to use our rounded values in our calculations. So let's try this one. All right, so angle A is an acute angle. So the angle given is acute. So I got to check in. I could have all 3 possibilities occurring. So the side opposite my given angle is greater than the side adjacent to my angle. So that means I have one triangle. So let's see, what's missing is angle B, angle C, and side C. All right. I want you to find the length of the measure of angle B first. So to do this, I set up my proportion as the sine of B over 5 is equal to sine of 31 degrees over 12. Solving for angle B, I'm going to multiply each side by 5 and then take the inverse sine. So the inverse sine of 5 sine of 31 degrees divided by 12 will equal approximately 12.3920. So my answer came on 12.29 degrees, but I'm going to use those 0.3920 in future calculations. So next thing I'm going to do is find the measure of side C, angle C. You can find this by taking 180 minus the two angles you know, the 31 and the 12.3920. And you find that the measure of angle C is 136 degrees, 136.608 degrees, or 136.61 degrees. Finally, I'm going to use the law of sines to find side C. So side C divided by the sine of 136.608 degrees divided by 12 divided by equal to 12 divided by sine of 31 degrees, multiplying each side by the sine of 136.608 degrees, and I end up that sine C is approximately 16.01. Okay, in this example, again, the angle given is 85 degrees, so that tells us it is acute. And then I compare the side opposite the angle given, which is the 15, and to the 25. This time, the side opposite the angle given is less than the side adjacent to the angle given. So in that case, I could be having either no triangle or two triangles occurring. We're not sure exactly which one yet. And so what I need to do is I need to figure out, is it two triangles or is it no triangle? In order to do that, I need to figure out my H value. If H is greater than A, there's no triangle. If H is less than the side opposite the given angle, then there's two triangles. So let's calculate H. H is equal to the side adjacent to the angle times the sine of the angle. When I calculate that in, I get H is approximately 24.90. Now, since A is less than H, I have no triangle. And I'm done. I can't do anything else in this problem. There's a way you can check this. Now, I sometimes can, like I just got up here, I got a little confused on my A's, B's, and H's. That happens to a lot of people. So let me show you a way that you can always figure out if you have no triangle. Now, that doesn't help you if you're between a 1 or a 2 triangle, but this helps you between no triangle. Let's say I just tried to solve this for angle B. So I set up my proportion using the law of sines like we've done in the last example. And I multiply each side by 25, and then I do the inverse sine of 25 over sine of 85 divided by 15. I punch this in my calculator. So let's do that. Make sure you're in degree mode. Okay, so let's find the inverse sine, so arc sine, of the fraction 25 times sine of 85 degrees divided by 15. Let's see what happens in our calculator when we push enter. No real answer, or you might get an error message in your calculator. That's your big red flag hint that there is no solution to this triangle, so no triangle can be formed. And so I decided, instead of remembering my rules, this is working you through, just seeing what your calculator gives you if you actually try to solve for our angle B. Okay, let's look at this next example. A is acute again, and we have the side opposite angle A is 6, and the side adjacent to angle A is 7. So we have our side opposite is less than our side that is adjacent. So that means that we need to figure out our H, our height of the triangle. And so height is equal to 7 sine of 30, or 3.5. Now, since that's the smallest measurement, then A is between our height and our side adjacent. That tells us we have two triangles. So how do we solve for both triangles in this situation? Well, first off, I'm going to set up my paper here that I'm going to solve for two triangles. And I'm going to have my triangle 1 over here on the left-hand side, my triangle 2 on the right-hand side. And let's identify what pieces we're missing from each triangle. Well, I'm given angle A, so I'm missing angle B and angle C. And I have sides A and B, so that means I'm missing side C for each of these triangles. So now I'm going to start by finding the measure of angle B by doing our law of sine. So sine of B is to 7, as sine of 30 degrees is to 6. Multiplying each side by 7. And then take the arc sine of each side to get our angle measurement. Now, I'm going to use these calculations in future calculations, so that's very important that I round to more double decimal places as I need. So I'm going to write my answer to 4 decimal places. But when I write my answer key, I only have to go to 2. So it's 35.69 degrees is measure of my first angle B. And now I need to find the second triangle's angle B. Now how you do this is these two angle B's are always supplementary angles, which means they add equal 180. So I just take 180 degrees minus the angle I found from my calculator. And again, I'm going to write all 4 decimal places, since I've asked you to go to 2 decimal places on this practice work here. And so my angle B for my second triangle is 144 degrees, 144.31 degrees. Okay, now that I have that basics, that foundations for each triangle, I'm pretty much just going to solve for angle C's and side C in each of these triangles. So let's go back to triangle 1. To find the measure of angle C, I recall that the sum of the angles of a triangle equal 180 degrees. So I take 180 degrees minus the 2 angles I know, which are 30 and the 35.6853 degrees. And that gives me angle C is approximately 114.3147 degrees. Now I'm going to use all 4 decimal places because I'm going to use this angle C in my next calculation to find the length of side C. So C is to sine of 114.3147, as 6 is to sine of 30. Multiply each side by that sine of the 114. And I find the length of side C in my first triangle to be approximately 10.94. Since I've finished solving my first triangle, let's go and finish solving our second triangle. So again, we're going to do the same thing. I figured out that my measure of angle B is 144.3147. I'm going to subtract that and 30 from 180 degrees to get the measure of angle C. And I find the measure of angle C is approximately 5.6853 degrees. So I'm going to use that to estimate in the law of sines to find the measure of side C. And side C is approximately 1.1888 or 1.19. Okay, let's check out the your turn problem. Our angle given for the side-side angle is an acute angle. And the measure the side opposite my acute angle is smaller than my adjacent side. So I have to find H. And H will be equal to 17 times the sine of 64 degrees, which is approximately 15.3. So since that's smaller than any of the other side measurements, since the hypotenuse is the smallest, that means I have 2 triangles. All right, so I know angle A and side A and B, so that means in each of these triangles, I need to find angle B, angle C, and side C. We'll start by solving for angle B by using our law of sines. So sine of angle B is 217 as the sine of 64 degrees is 216. We'll solve this for angle B. And we get B is approximately 72.7401. So we're going to use that more exact angle measurement to calculate the other angle B by remembering that those two angle B's are always supplementary to each other. So I'll take 180 minus the answer I just received, and that gives me my second angle B of 107 degrees, 107.2599 degrees. Going back to triangle 1, let's solve for angle C by taking 180 minus the given angle of 64 minus the angle B we found of 72.7401. And we find that measure of angle C is 43, measure angle C for triangle 1 is 43.2599. And then we're going to use that more exact answer to calculate the length of side C by using our law of sines. And we get side C in the first triangle is approximately 11.75. Now let's solve for triangle 2. Beak C2 for our triangle 2 would be 180 degrees minus our given angle of 64 degrees minus our angle of 107.2599, which would be approximately 8.7401 degrees, or 8.74 degrees. Using the law of sines to find our missing side C, we get the side C is approximately 2.7051 or 2.71. That's how you solve if you're given two triangles. Now let's look at an example. We have an obtuse angle given. So this is still side-side angle, but this time the obtuse angle is given. So we only have two possibilities of solutions that we can have with obtuse angles. Remember for my table up here that this means we'll either have no triangle or one triangle. Two triangles is not a possibility with obtuse triangles. So we have no triangle if the side opposite the given angle is less than or equal to the side adjacent. And we will have exactly one triangle if the side opposite the given angle is greater than the side adjacent. That's the only rules you have to remember with obtuse triangles. So since we only have one little rule there, that's the only reason I put one example of an obtuse angle on here. So the side opposite my given angle would be the 61. The side adjacent would be the 46, since the angle C was given. So since my side opposite is larger than my side adjacent, that means I will have a triangle. So I can just set up my law of sines, and we'll start by solving for sine of B. Well, I need to find angles A, angles B, and side A. We'll start by finding angle B. So sine of B is to 46 as the sine of 103 is to 61. And then we'll solve this using the law of sines. Now, as I'm solving this on my paper, I do want to make one little note that might be important to notice. Now, because the obtuse angles only have two possibilities, one triangle or no triangle, this is an example of where that no triangle one, you can just start by straight going in, plugging it in to the law of sines. And if you get an error on your calculator, that means it's a no triangle solution. If you get an answer that makes sense on your calculator, not a negative answer, then you have a triangle that's formed, and keep going. Because sometimes you might not get an error, but you'll get a negative angle measurement, which does not make sense in these situations. So I found my angle B to be 74.29. So now I'm finding my angle A by subtracting the two known angles from 180. And my angle A is 29.71. Now notice I am using 4 decimal places because I need to use this angle A in my next law of sine setup to find my side A. And as you can see, I can solve this equation, and I end up that my missing side is 31.03.